Hi guys, greetings from CALQ. Today I'm going to show you how to investigate a singly reinforced beam under transition zone using CALQ RCBM. Okay, so we have here this reference manual of CALQ RCBM, and if we uh, look for the contents here, so bali yung i-analyze natin is itong investigation problem transition zone. No? So if we double click on this one, so ito yun. No? Ayan. So, yung problem dito, analyze natin yan using this CALC RCBM. Okay, so click lang natin to. So, the reference manual is also interactive. So, click lang natin yan. And then, we will be directed on this page. No? So, to solve natin yung problem na to, we have a rectangular concrete beam having a width of 330 mm and effective depth of 450 mm is reinforced with 625 mm diameter rebars. So assume FC prime is 27.5 megapascal and Fy is 414 megapascal. So use 2010 or 2015 NECP code provision and determine the capacity over demand ratio if your maximum applied moment is 300 kilonewton meter, and also determine the capacity over demand ratio if your maximum applied moment is 400 kilonewton meter. So, bali dito sa reference manual is, andito na din yung conventional na solution. Ha? So, ayan. So, conventional solution. Step by step. Ayan. And then, ayan. So, makita natin dito na yung result niya is for A, kung yung maximum applied moment is 300 kilonewton, that is safe, no? Kasi greater than 1. So, which means that capacity is uh, greater than demand. While if yung maximum applied moment natin is 400 kilonewton, or yung demand is 400 kilonewton meter, so meaning mas malaki yung demand compare dito sa capacity. So makita natin na less than 1 siya, di ba? Kasi yung capacity natin is 378. So which is uh, inadequate. So we need to redesign. So anyway, and dito din sa reference manual is sinolve din natin yan using CALC RCBM. Na? So, ngayon, solve natin yung problem na to in action. No? But anyway, user have a reference manual para guided kayo on how to use the CALC RCBM. Okay, so let's solve this problem. First is, let's open the application. And then we log in. Huh? So, if you're a registered user, so you just directly log in. Okay. So, since yung tanong is ano daw yung capacity over demand ratio, so we know that this is under investigation problem. No? So, just click on getting started, and then ito yung pipiliin natin yung investigation process. So, ngayon sa investigation process is makikita natin dito na ito yung given, tension bars. So, assume na lang natin na singly reinforced. Singly rectangular beam. Okay? And but you have also a checker if singly reinforced pa talaga siya. Yeah? Anyway, since ito is alam ko na singly reinforced, patuloy na lang tayo. No? Pero anyway, later, i-check din natin kung totoo ba talagang singly reinforced beam to or baka naman doubly reinforced beam to. Okay. So, click lang natin to. Ayan. Anyway, may example din ako nito. Huh? You can load an example, but I want to start from scratch. No? So, bali dito, ito yung beam width. So, click lang natin to. And then, let's type yung beam width which is 330. Type 330. So, yung effective depth is given 450. So, let's type 450. So, yung cover is 40. Anyway, if you click on this folder icon, okay. So, ayan. So, if you click on this folder icon, you can see this specified concrete cover requirements. No? Ayan. Okay, so anyway, let's close that one. Tala yung concrete cover is hindi naman talaga siya, hindi ko siya sinali sa computation. So, anyway, just click save. And then, dito naman, click natin yung FC prime. If you click on this folder, and so, makikita mo rin yung concrete design properties. Again, kinuha ko to sa 2015 na NCP code. Anyway, gusto muna natin to. Yung FY naman, click natin yan. So, dito din yung sa FY, no? Again, kinuha ko dito sa 2015 na NCP code. Okay, so yung FC prime is 27.5. And then yung FY is 414. So let's say 23.5 and let's calculate the beta. So yung beta calculation dito is naka-base sa 2015 na ADCP. Click natin ito. Ayan. So ito yan, no? So dapat may minus pa to eh, no? Dito. So I think typo error yun sa anyway, close this one and then let's calculate. So 0.85. So anyway, kung titignan natin yan dito sa conventional, ayan, no? So pag less than siya ng 28 megapascal, so matic na yung beta factor is 0.85. Okay, so then here, number of bars. Dito sa problem is meron tayong 6. So type natin 6 dito. We have 6. And then diameter ng bar is we have 25. So 25 din yung lalagay natin dito. And then we can calculate for steel area. You can round it up, no? May edit mo man to, no? Anyway, I'll stick with that. And then yung stirrup diameter, okay. So type naman tayo. Though hindi naman siya given dito, so assume muna ako. Anyway, so kinayan, save. So dito naman. So unahin muna natin isolve itong situation, part A, no? Where yung demand is 300 kilonewton. So type lang natin dito yung 300 and then click save. So pagkatapos nyan is pwede na tayo mag-run analysis. So click run analysis and then hintayin na lang natin na matapos mag-calculate si CALQ RCBM. So ayan na, ha? So nakikita natin dito yung step by step na calculation. And so we can have the depth of compression block, location of neutral axis, the nominal moment capacity. Diba? So kung titignan natin yan dito, and ito sa reference manual, yung nominal moment capacity niya is 452.328, no? So, pareho. 452.328. Okay, so tuloy tayo. So, since yung Fy natin is less than Fs, I mean, yung Fs is greater than Fy, but less than 1,000 megapascal, so which means that this is under transition zone. No? So, yeah, ito yung kita mo, no? So, naka-sheet yung transition zone. So, yung gagamitin natin na phi factor is itong 0.65 plus 0.25 na Fs minus Fy over 1,000 minus Fy. So, yung nakuha natin is 0.836. So, ngayon, yung MU natin, yung capacity is 378.51. So, titignan natin yan dito sa maximum capacity. Ito na pala yan. So, yung maximum capacity niya dito, ito na pala, is 378.5092. So, the same value na. So, meaning yung capacity over demand ratio niya is 1.262. So, which means that is safe. So, the same siya sa conventional. Though makikita mo yung CALQ RCBM is mag-generate talaga siya na parang conventional din na computation. Okay? So, ngayon is yung B, which is yung applied moment is 400. So, yung gagawin lang natin, punta lang tayo dito sa icon na to. Then, so change lang natin to into 400. So, provided na the same lahat ng values. And again, then we can now run. Okay, so so may expected natin makukuha dito is 0.9463 and that is not safe. So ayan na. So we have now the conventional solution generated by CALQ RCBM. So bottom line is makita natin dito na yung capacity over demand ratio is 0.946. Okay, 946, which is the same. That is not safe, so we need to read this. So yun yun. Na? So I hope you find the CALQ RCBM useful, and thank you for listening. God bless everyone. Keep safe.